You have been doing something in your kitchen that feels completely harmless. You do it several times a week, maybe every day. You do it quickly, without thinking, because it is one of the most ordinary things a person can do with food. You cook. You have leftovers. You put them in the refrigerator. The next day, you take them out and heat them up again. The microwave hums. The plate is warm. You eat. And the cycle continues, efficient and practical, the way most people manage food in a busy life. But for 5 specific foods, the act of reheating is not neutral. It is a chemical event, a transformation that occurs in the molecular structure of the food itself, producing compounds that are not present when the food is freshly cooked and that, with repeated exposure, contribute to one of the most serious health risks the modern diet silently carries. These compounds are not in the news. They are not on the label. They form silently during the heating process and disappear into the food you eat with no visible warning, no unusual smell, no altered taste that would tell you something has changed. And the 5 foods that produce them most significantly are not exotic or unusual. They are the staples. The foods most likely to be sitting in your refrigerator right now, waiting to be reheated for tomorrow's lunch. The word that connects these 5 foods is not a word most people associate with cooking. It is carcinogen, a cancer-causing compound formed through specific chemical reactions that are triggered or amplified by repeated heating, cooling, and reheating cycles in certain categories of food. The research on these reactions is not fringe science or alarmist speculation. It is published in peer-reviewed journals of food chemistry, toxicology, and epidemiology. It is taken seriously by food safety regulatory agencies. And it is almost entirely absent from the practical cooking knowledge of the vast majority of people who are eating reheated versions of these foods regularly, in the sincere belief that they are doing something as ordinary and as safe as making lunch. This is Dr. Victor Lang, and the reason this channel exists is for exactly this conversation, the kind that does not happen in a standard doctor's appointment, that does not appear on the packaging of any of these foods, but that the evidence says people deserve to have. If this is where you want to keep getting information, this specific and this directly relevant to the food decisions you make every day, hit like and subscribe right now. What follows is going to change what you do with your leftovers. Let us start with the food that is most likely to be in your refrigerator right now, and that carries the most well-documented reheating risk of anything on this list. Rice. Cooked white or brown rice that is refrigerated and then reheated is not simply a convenient leftover. It is a food that, depending on how it was handled between cooking and reheating, can carry one of 2 distinct categories of risk. The first is bacterial, involving Bacillus cereus, a heat-resistant spore-forming bacterium that can survive the initial cooking process, multiply during improper cooling or room temperature storage, and then survive reheating at temperatures that kill most other foodborne bacteria. But the bacterial risk, while real and important, is the risk that food safety education has already communicated to some degree. The chemical risk of repeatedly reheated rice is the one that receives far less attention, and that is more directly relevant to the cancer conversation. Rice is a carbohydrate-dense food, and when starchy foods are heated to high temperatures, the Maillard reaction, a chemical reaction between amino acids and reducing sugars, produces a family of compounds including acrylamide, a compound classified as a probable human carcinogen by the International Agency for Research on Cancer. Acrylamide forms when starchy foods are cooked at high temperatures, and each successive heating cycle of the same rice generates additional acrylamide, with the concentration increasing measurably with each reheat. The World Health Organization has identified acrylamide as a food contaminant of concern, and studies on dietary acrylamide exposure have found associations with increased risk of several cancers, particularly endometrial, ovarian, and kidney cancers in women, and with increased oxidative DNA damage that is a precursor step to cancer development across multiple organ systems. The microwave heating method most people use for reheated rice generates localized hotspots that can reach temperatures significantly higher than boiling, intensifying the Maillard reaction in the outer portions of the rice while leaving the center cooler, producing an uneven acrylamide distribution that makes the total exposure difficult to predict but consistently adds to it. Reheating rice once, quickly, at moderate temperature, from properly refrigerated storage, poses significantly lower risk than repeatedly cycling the same rice through multiple reheat events, which is the pattern that most meaningfully amplifies the concern. The second food on this list is one that almost nobody connects to carcinogen formation, because its reputation in health culture is so overwhelmingly positive that placing it in a video titled "With Cancer Risk" feels almost counterintuitive. Spinach and other nitrate-rich leafy greens, when cooked, refrigerated, and reheated, undergo a chemical transformation that converts the naturally occurring nitrates in these vegetables into nitrites and subsequently into N-nitrosamines, a class of compounds that are among the most studied chemical carcinogens in the food science literature. The nitrogen chemistry behind this transformation is straightforward. Raw spinach contains high concentrations of naturally occurring nitrates, which are not themselves harmful, and which serve as the dietary substrate for nitric oxide production in the body. When spinach is cooked, the naturally occurring enzymes that regulate nitrate metabolism are deactivated by heat. When the cooked spinach then cools and is stored in the refrigerator, bacterial activity begins converting the nitrates into nitrites through a process that does not require the heat of cooking to proceed. When the nitrite-enriched spinach is then reheated, the heat drives the further conversion of nitrites into N-nitrosamines in the presence of the amino acids in the food through a chemical reaction that is accelerated by heat and by the acidic conditions that develop in reheated plant material. N-nitrosamines have been designated as probable or possible human carcinogens by research agencies globally, and epidemiological studies have found associations between dietary N-nitrosamine exposure and increased risk of gastric, esophageal, and colorectal cancers. The recommendation from food safety researchers is not to avoid cooked spinach or other nitrate-rich greens, which are genuinely nutritious foods when freshly prepared. The recommendation is to avoid reheating cooked spinach, and instead to consume leftover cooked spinach cold in salads or mixed dishes where it is not subjected to the second heat cycle that drives the most dangerous phase of the nitrogen transformation. The third food is one that sits at the center of the modern meal prep culture, and that millions of people reheat multiple times per week in the sincere belief that they are managing their protein intake efficiently and healthfully. Chicken, specifically cooked chicken that is refrigerated and then reheated, particularly when it is reheated repeatedly or at high temperature. The issue with reheated chicken involves the transformation of its protein structure and the formation of two categories of compounds that have direct carcinogenic concern in the research literature. The first are heterocyclic amines, abbreviated as HCAs, which form when the proteins and creatine in muscle meat react at high temperatures. HCAs are formed in significant concentrations during the original high-heat cooking of chicken, particularly when it is grilled, fried, or broiled. But here is what most people do not know. When cooked chicken is reheated to high temperatures, particularly in a hot pan, a toaster oven, or under a broiler, the HCA formation continues. The proteins in the already cooked meat undergo further structural changes that produce additional HCA molecules with each subsequent heating event. The International Agency for Research on Cancer has classified several specific HCA compounds as possible human carcinogens, and epidemiological studies have found associations between high dietary HCA exposure from meat consumption and increased risk of colorectal, pancreatic, and breast cancers. The second compound category of concern in reheated chicken is oxidized protein byproducts, specifically protein carbonylation products that form when oxidative stress during reheating attacks the amino acid side chains of the muscle proteins. These carbonylation products are markers of oxidative damage that contribute to the inflammatory environment associated with cancer development, and their concentration increases with successive reheating cycles. The practical harm reduction for chicken is not to avoid eating it as a leftover, but to reheat it gently, using methods that minimize temperature extremes, such as steaming or reheating in a small amount of liquid rather than in a dry hot pan, and to limit the number of times any individual portion of chicken is cycled through the cooling and reheating process. One reheat, done gently from properly refrigerated storage, differs meaningfully from the multiple reheat pattern that maximizes the HCA and protein oxidation products reaching the plate. The fourth food carries the most surprising chemistry on this list because it is a food that most people associate with simplicity and nutritional neutrality. Eggs. Scrambled eggs, hard-boiled eggs, omelets, or any cooked egg preparation that is refrigerated and then reheated undergoes a specific chemical transformation involving the oxidation of cholesterol in the egg yolk. Cholesterol oxidation products, abbreviated as COPs, are a class of compounds formed when the cholesterol in egg yolk is exposed to heat in the presence of oxygen. Initial cooking of eggs produces COPs at a certain baseline level depending on the cooking method, with high heat methods like scrambling or frying producing more than gentle methods. When cooked eggs are then refrigerated and reheated, particularly in a microwave, which generates uneven heat and local hotspots, the oxidation of cholesterol continues. The COPs that result from this progressive oxidation include compounds that have been documented in cell culture studies to be cytotoxic, atherogenic, and potentially mutagenic at the cellular level. Research published in food chemistry journals has found that COPs in reheated egg preparations can reach concentrations several times higher than in freshly cooked eggs. Epidemiological research on dietary COP intake and cancer risk is less definitive than the mechanistic cell culture evidence, but the accumulation of data on cholesterol oxidation products as contributors to cellular DNA damage and the inflammatory microenvironment that favors cancer development is sufficient to place reheated eggs in the category of foods where the pattern of preparation meaningfully influences the biological risk of the resulting meal. Eggs freshly cooked and consumed immediately produce COPs at a much lower level than eggs that have been cooked, refrigerated, and then reheated at high temperature. The simple shift from reheating eggs to cooking them fresh each time removes this category of risk almost entirely, and given how quickly eggs cook from raw, this is one of the most accessible harm reduction adjustments on this list. The fifth food is one where the chemistry is perhaps the most clearly documented and the most directly relevant to cancer risk in the research literature: processed meats that are reheated, including deli meats, bacon, sausages, and other cured meat products. Processed meats already contain nitrites added during the curing process as preservatives, which is a separately documented cancer risk for colorectal cancer that has led the World Health Organization to classify processed meats as Group 1 carcinogens, meaning the evidence that they cause cancer in humans is sufficient for classification. But the reheating of processed meats takes this pre-existing nitrite content and drives it further along the same nitrogen chemistry pathway we described for spinach, nitrites reacting with the amino acids in the meat protein under heat to produce N-nitrosamines. Studies specifically examining the N-nitrosamine content of bacon before and after frying have found that frying increases N-nitrosamine concentrations substantially, and that the use of higher frying temperatures produces greater N-nitrosamine formation than lower temperature cooking, when already cooked bacon or other processed meats are then reheated a second time, whether in a microwave, a pan, or an oven. This chemistry runs again. The N-nitrosamine burden in the meat increases with each heat cycle applied to the already nitrite-rich processed meat product. The dose-response relationship between dietary N-nitrosamine intake and colorectal cancer risk is one of the better characterized relationships in dietary cancer research, and reheating processed meats, particularly at high temperatures, represents one of the most preventable points of amplification of this specific carcinogenic compound class in the everyday diet. Now let us step back from the 5 foods and address the larger framework that makes all of this information actionable rather than simply alarming, because the goal of sharing this information is not to create anxiety about eating or to suggest that eating leftover rice once last week has set an irreversible biological event in motion. Cancer is a disease of cumulative exposure and accumulation. Single exposures to the compounds discussed here do not cause cancer. Habitual, repeated exposure over years and decades, combined with the other oxidative and inflammatory inputs that characterize modern dietary patterns, contributes to the cumulative biological environment in which cancer becomes more likely. Reducing these specific sources of repeated carcinogen exposure is not about eliminating risk with any individual meal. It is about reducing the cumulative exposure that the body manages across thousands of meals over a lifetime. The harm reduction strategies that emerge from this understanding are practical and specific. For rice, cook only what you will eat in a single meal, or accept the first reheat as acceptable while treating the same rice more than once as a pattern to avoid. For spinach and nitrate-rich greens, eat leftovers cold rather than reheating, incorporating them into cold salads, wraps, or room temperature grain bowls where they do not require a second heat cycle. For chicken, reheat gently in steam or broth rather than dry high heat, and limit successive reheat cycles of the same portion. For eggs, cook fresh rather than reheating, taking advantage of the fact that eggs are among the fastest foods to prepare from scratch. For processed meats, the most meaningful intervention goes beyond just reheating practices to the baseline consumption decision, but when they are consumed, Minimizing the total number of heat cycles applied reduces the N-nitrosamine burden at each serving. The broader lesson underneath the 5 specific foods is one about the relationship between heat, time, and chemistry in cooked food. Every cooked food is a collection of transformed molecules, and some of those transformations continue with each subsequent thermal event the food is subjected to. The assumption that reheating food is simply warming it back to an eating temperature without chemically altering it is incorrect for the specific food categories and specific chemical pathways we have been discussing. Understanding that reheating can be a chemical event with biological consequences allows you to make more specific choices about which foods to reheat and how, and which foods to consume fresh each time as a consistent practice. There is something that feels dissonant about learning that something as ordinary and as practical as reheating leftover food can carry chemical risk. The kitchen is supposed to be the place where care and nourishment are expressed, where the preparation of food is an act of ordinary love rather than a source of hidden harm, and it remains that. But informed care is more protective than uninformed care, and the knowledge that specific chemical transformations occur in specific foods under specific conditions is not a reason to fear the kitchen. It is a reason to use it a little more thoughtfully, to consider which leftovers to reheat and which to consume cold, to recognize that the microwave is not always neutral, to remember that the most ordinary seeming actions accumulate into the biological environment that determines health outcomes over decades. The 5 foods in this video are not going to change overnight, and neither should your relationship with them, but the specific knowledge you have now about the chemistry behind the risk, about the conditions that produce it, and about the practical adjustments that reduce it most meaningfully, gives you something that the millions of people reheating these same foods right now without this information do not have. It gives you the ability to make a different choice when it matters. Tell me in the comments which of these 5 foods surprised you the most, and which one you will be handling differently starting tonight. Your experience in this comment section helps the next person who arrives here, unsure whether to take the risk seriously or to dismiss it, find the answer in the voice of someone who thought it through alongside them. And please share this video with the people in your life who are managing leftovers the way most people do, without any awareness that the way a food is reheated can matter as much as what the food is. Because the gap between knowing this and not knowing it is the gap between a habit that quietly contributes to long-term risk and a habit that has been made a little safer by the simple act of being informed. What you heat changes what you eat. Now you know which 5 foods to think twice about before pressing start on the microwave.